Good morning. First, I thought I'd describe two groups of beneficial fungi that are important to forestry. Many of you will be familiar with the mycorrhiza group of fungi. They're often visible on the outside of roots. Trichoderma is another fungi, also found on the outside and often on the inside. Oops, beg your pardon. On the inside of roots, but these are not visible to the naked eye. When they're inside, they're called endophytes, and there's an image in the top middle, and this is the Trichoderma hyphae that's been stained with yellow-green fluorescent dye, and it's inside a piece of root, and you can see the hyphae growing between the root cells. So, a Trichoderma root endophyte is a naturally occurring fungus found in the soil and in the roots. It has a symbiotic or a mutualistic relationship with plants. And the benefits of Trichoderma include the ability to promote plant growth. It can activate the plant's defense system. It can be aggressive against other fungi. It can increase the plant's tolerance to different stresses, and it can improve plant nutrient uptake. So Trichoderma fungi are doing a similar job to the mycorrhiza. Luckily, Trichoderma is easy to grow and propagate, and it's easy to use in the nursery. Now, the management of foliar diseases, needle diseases, that often involves the inputs of agrochemicals, but as we are aware, recently there's been emphasis on finding more sustainable ways to operate, and there's been pressure to reduce or eliminate these agrochemicals. So naturally occurring organisms like Trichoderma offer a non-chemical alternative for disease control and growth promotion. Now, the Trichoderma Pine Research Program. The main aim of this work is to reduce the foliar disease losses using these beneficial Trichoderma root endophytes, both by suppressing disease and enhancing the growth in nurseries and plantations. Now, this will reduce chemical use and improve the growth in the nurseries. It will lead to healthier forests with faster growth. And just as importantly, as we've been hearing, it will protect against pathogens that haven't arrived yet. So I'm just quickly going to run through the program, what's happened so far. First, there's been a large selection of Trichoderma endophyte strains that have been taken from the roots of very healthy, strongly growing plants. So not only from Pinus radiata, but also from other crops, weeds, gardens, ornamental plants. Now, this work was pioneered by Dr. Robert Hill, who's in the audience here today. Hello, Robert. The next step was testing hundreds and hundreds of these Trichoderma strains. They were tested in containerised nursery trials for their growth benefits. They were also challenged against foliar needle diseases, and the most effective Trichoderma strains for increasing growth and the health of the pine seedlings were selected. Now, these inoculated seedlings were planted out into about 20 plantation trials from Nelson to Northland, and we've been measuring these results over time. And we've found that Trichoderma increases early tree growth in many of the trial sites, and it was often in sites with growth limitations. So we just quickly summarise some of the results. We've been getting up to a 20% increase in height in young trees in the first 12 months. There was an average 6% reduction in mortality from disease, again at 12 months. We've been getting up to a 19% increase in DBH at year 3, and up to a 17% increase in tree height once they've got to about 5.5 years. And also we're finding that if the benefits are there during early growth, they tend to be maintained over time. Now, we're just starting to measure the impact of Trichoderma on foliar disease. So this is the results of a Dothostroma measurement in a Trichoderma in a Kayangaroa forest trial. And we found that disease severity was significantly reduced by about a third to a half in the trichoderma treatment. They were T4 and T5. That's the darker green bars there, and that was compared to the control. So we've got a large reduction in disease here with trichoderma. Another result is, again, a dothostroma measurement in an Owakuni forestry trial. In this case, the trichoderma T3 measurement significantly reduced disease severity by 60% compared to the control. So what we're finding is that trichoderma nursery seed treatment can be, or definitely is, reducing disease, but just be aware that it's not fully eliminating it out in the field. The next step was to set up 8 large validation trials. These were set up in winter 2018, and they were quite large at 2 to 3 hectares in size. So the 2 most effective, the 2 best trichoderma treatments that were selected from those previous national trials that I've just described were chosen, and they're called the PR6 mixture, the PR3A mixture, and these are going to be compared against an untreated control. 4 regions were chosen: Gisborne, Northland, Nelson, Bay of Plenty, Waikato, and 2 sites were also chosen per region. So one was a high altitude, so a nominal colder site, and the other was a lower altitude, a nominal warmer site. The trials had a robust statistical design, 81 trees per plot, and also had good replication at 7 to 10 reps per trial. So we're just going to quickly run through the results. In the first graph on the left, we're looking at the Bay of Plenty Waikato trials in Kaingaroa Forest. The bar on the left-hand side is the PR6 trichoderma treatment, and it gave a significant increase, 11% increase compared to the control. Onto the next site in Kaingaroa, again PR6 this time gave a 15% increase in tree height at year 1 compared to the control. Move across to the right-hand side, in Gisborne, the first site, PR6 again gave a significant increase in tree height at 7%, and at the second site, this time it was the PR3A that gave the significant increase at 7%. So moving on to the Northland trials, on the left-hand side, at the warmer site, or meant to be warmer site, this time it was the PR3A trichoderma treatment gave an 11% increase in tree height compared to control. And at the second site, both trichoderma treatments gave a significant increase at 9%. The only region where there was no difference was in the Golden Down trials, that was in Nelson. So when you analyse all the data together over the 8 trials, both trichoderma treatments applied as a seed coat, and this was 2 years earlier, gave a significant boost to early growth in the plantation, a 6 and 7% significant increase. So we thought this was a great result, and the only dilemma is, which is the best, the most efficient trichoderma mixture. Now, some of the other work that I've been looking at is whether trichoderma can improve root initiation and growth in the nursery, and this is looking in difficult-to-root clones, these important clones that we're starting to work with. I've set up 2 Pinus radiata trials using these difficult-to-root clones, and it was found that trichoderma had a really big impact on the growth of these clones. So if you look at the graph in the middle, the 5 trichoderma treatments gave up to a 61% increase in the number of plants that had good root scores. The most beneficial trichoderma treatments also gave a big increase in survival, a 38% increase in the number of plants with large root collars, and most importantly, a 75% increase in the number of marketable cuttings, production cuttings. So these are plants with large plants and good root scores. So in this case, trichoderma was highly beneficial to rooting and growth of these important clones. Okay, I'm starting to work on the effects of trichoderma in other forestry species. What I've found in 2 large trials is that trichoderma and Douglas fir, they're highly compatible. I'm getting really high root colonisation scores at 12 months. So if we look at the graph on the right-hand side, most of the trichoderma treatments significantly increased survival, and the best one was up to a 10% improvement. If we look at the next graph, we look at dry weight. Again, most of the trichoderma treatments gave a large improvement in plant dry weight. The best one was up to 45%. Okay, an important question to answer for us is, does trichoderma persist in these inoculated trees once they're planted out into the plantation? In terms of seedlings, we're consistently getting really good colonisation and persistence of trichoderma in the roots of nursery plants. This is in pines, Douglas fir and cypress. But what happens when you put these inoculated seedlings out into the plantation? Now, we have a sensitive molecular test available, and we were able to show that samples in 6 forests had the majority of the trees still had the presence of the trichoderma that was applied as a seed coat. So that would have actually been 4.5 years prior to that. So we're really happy with this persistence and seeing that it's come through. Just while I'm here, I've got that image on the right-hand side. It's just another image of what trichoderma looks like when it's colonised a root piece. This is inside the root piece. And you can see that high association between the trichoderma hyphae and the root cells. Another important question is, can trichoderma treatments mitigate disease in established trees? So the most cost-effective practical way of applying trichoderma is in the nursery, either as a seed coat or as a soil drench. But can we apply trichoderma to established plantation trees? Can we use it as a top-up on a forestry scale? So I've set up 2 proof-of-concept trials in the Bay of Plenty, and we've found that you can introduce trichoderma into the roots of established trees, and you can also generate a growth improvement. But obviously we need a more practical way of introducing trichoderma into the forest, not using obviously injectors or dowels. So we've set up 2 new trials with trichoderma applied to the foliage and to the ground in 2 trials in Bay of Plenty this spring. Okay, thank you. Just quickly running through other ongoing or future work that we've been looking at. As I say, working with more forestry species. So can trichoderma improve the growth and control canker in cypress? We're looking at, can trichoderma control Swiss needle cast in Douglas fir? Should we be targeting these trichoderma strains to different environments, different regions? What is the impact of nursery chemicals on colonisation and persistence of trichoderma strains? And can trichoderma be used to boost poor soils in nurseries? Conclusions are that trichoderma root endophytes can significantly improve plant growth in the nursery, and we're finding early indications that trichoderma inoculated plantation trees may have less foliar disease than untreated trees. Just like to reiterate that nursery seed coating or drenching is the most efficient way to introduce trichoderma into the forestry system. So these results have given us the confidence to begin the commercialisation discussion process of using these beneficial trichoderma mixtures as biocontrol agents in New Zealand forestry. And the last slide is just a great big thank you to all these industry people for their superb work. Or superb input into the trial work. And as mentioned before by many speakers, most of my work just wouldn't happen without their help. Thank you.